A planet is an astronomical object orbiting a star or stellar remnant that is massive enough to be rounded by its own gravity, is not massive enough to cause thermonuclear fusion, and has cleared its neighboring region of planetesimals. The term planet is ancient, with ties to history, science, mythology, and religion. Several planets in the Solar System can be seen with the naked eye. These were regarded by many early cultures as divine, or as emissaries of deities. As scientific knowledge advanced, human perception of the planets changed, incorporating a number of disparate objects. In 2006, the International Astronomical Union officially adopted a resolution defining planets within the Solar System. This definition is controversial because it excludes many objects of planetary mass based on where or what they orbit. Although 8 of the planetary bodies discovered before 1950 remain planets under the modern definition, some celestial bodies, such as Ceres, Pallas, Juno and Vesta, and Pluto, that were once considered planets by the scientific community, are no longer viewed as such. The planets were thought by Ptolemy to orbit Earth in deferent and epicycle motions. Although the idea that the planets orbited the Sun had been suggested many times, it was not until the 17th century that this view was supported by evidence from the first telescopic astronomical observations performed by Galileo Galilei. By careful analysis of the observation data, Johannes Kepler found the planets' orbits were not circular but elliptical. As observational tools improved, astronomers saw that, like Earth, the planets rotated around tilted axes, and some shared such features as ice caps and seasons. Since the dawn of the space age, close observation by space probes has found that Earth and the other planets share characteristics such as volcanism, hurricanes, tectonics, and even hydrology. Planets are generally divided into two main types: large low-density giant planets, and smaller rocky terrestrials. Under IAU definitions, there are 8 planets in the Solar System. In order of increasing distance from the Sun, they are the 4 terrestrials: Mercury, Venus, Earth, and Mars, then the 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. 6 of the planets are orbited by one or more natural satellites. More than 2,000 planets around other stars have been discovered in the Milky Way. As of the 24th of December 2015, 2014 known extrasolar planets in 1292 planetary systems, ranging in size from just above the size of the Moon to gas giants about twice as large as Jupiter. On December 20, 2011, the Kepler Space Telescope team reported the discovery of the first Earth-sized extrasolar planets, Kepler-20e and Kepler-20f, orbiting a Sun-like star, Kepler-20. A 2012 study, analyzing gravitational microlensing data, estimates an average of at least 1.6 bound planets for every star in the Milky Way. Around 1 in 5 Sun-like stars is thought to have an Earth-sized planet in its habitable zone. History. The idea of planets has evolved over its history, from the divine wandering stars of antiquity to the earthly objects of the scientific age. The concept has expanded to include worlds not only in the Solar System, but in hundreds of other extrasolar systems. The ambiguities inherent in defining planets have led to much scientific controversy. The 5 classical planets, being visible to the naked eye, have been known since ancient times and have had a significant impact on mythology, religious cosmology, and ancient astronomy. In ancient times, astronomers noted how certain lights moved across the sky in relation to the other stars. Ancient Greeks called these lights pi lambda alpha nu eta tau epsilon sigma sigma tau epsilon rho epsilon sigma, or simply pi lambda alpha nu tau alpha iota, from which today's word planet was derived. In ancient Greece, China, Babylon, and indeed all pre-modern civilizations, it was almost universally believed that Earth was the center of the universe and that all the planets circled Earth. The reasons for this perception were that stars and planets appeared to revolve around Earth each day, and the apparently common-sense perceptions that Earth was solid and stable and that it was not moving but at rest. Babylon, the first civilization known to have a functional theory of the planets, were the Babylonians, who lived in Mesopotamia in the 1st and 2nd millennia BC. The oldest surviving planetary astronomical text is the Babylonian Venus tablet of Ammisaduqa, a 7th century BC copy of a list of observations of the motions of the planet Venus, that probably dates as early as the 2nd millennium BC. The Mul-Apan is a pair of cuneiform tablets dating from the 7th century BC that lays out the motions of the sun, moon and planets over the course of the year. The Babylonian astrologers also laid the foundations of what would eventually become Western astrology. The Enuma Anu Enlil, written during the Neo-Assyrian period in the 7th century BC, comprises a list of omens and their relationships with various celestial phenomena, including the motions of the planets. Venus, Mercury and the outer planets Mars, Jupiter and Saturn were all identified by Babylonian astronomers. These would remain the only known planets until the invention of the telescope in early modern times. Greco-Roman astronomy. The ancient Greeks initially did not attach as much significance to the planets as the Babylonians. The Pythagoreans, in the 6th and 5th centuries BC, appear to have developed their own independent planetary theory, which consisted of the Earth, Sun, Moon, and planets revolving around a central fire at the center of the universe. Pythagoras, or Parmenides, is said to have been the first to identify the evening star and morning star as one and the same. In the 3rd century BC, Aristarchus of Samos proposed a heliocentric system, according to which Earth and the planets revolved around the Sun. The geocentric system remained dominant until the scientific revolution. By the 1st century BC, during the Hellenistic period, the Greeks had begun to develop their own mathematical schemes for predicting the positions of the planets. These schemes, which were based on geometry rather than the arithmetic of the Babylonians, would eventually eclipse the Babylonians' theories in complexity and comprehensiveness, and account for most of the astronomical movements observed from Earth with the naked eye. These theories would reach their fullest expression in the Almagest written by Ptolemy in the 2nd century CE. So complete was the domination of Ptolemy's model that it superseded all previous works on astronomy and remained the definitive astronomical text in the Western world for 13 centuries. To the Greeks and Romans there were 7 known planets, each presumed to be circling Earth according to the complex laws laid out by Ptolemy. They were, in increasing order from Earth, the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn. India. In 499 CE, the Indian astronomer Aryabhata propounded a planetary model that explicitly incorporated Earth's rotation about its axis, which he explains as the cause of what appears to be an apparent westward motion of the stars. He also believed that the orbits of planets are elliptical. Aryabhata's followers were particularly strong in South India, where his principles of the diurnal rotation of Earth, among others, were followed, and a number of secondary works were based on them. In 1500, Nilakantha Somayaji of the Kerala School of Astronomy and Mathematics, in his Tantra Sangraha, revised Aryabhata's model. In his Aryabhatiyabhasya, a commentary on Aryabhata's Aryabhatiya, he developed a planetary model where Mercury, Venus, Mars, Jupiter and Saturn orbit the Sun, which in turn orbits Earth, similar to the Tychonic system later proposed by Tycho Brahe in the late 16th century. Most astronomers of the Kerala school who followed him accepted his planetary model. Medieval Muslim astronomy. In the 11th century, the transit of Venus was observed by Avicenna, who established that Venus was, at least sometimes, below the Sun. In the 12th century, Ibn Bajjah observed 2 planets as black spots on the face of the Sun, which was later identified as a transit of Mercury and Venus by the Maraha astronomer Qutb al-Din Shirazi in the 13th century. Ibn Bajjah could not have observed a transit of Venus because none occurred in his lifetime. European Renaissance. With the advent of the scientific revolution, use of the term planet changed from something that moved across the sky to a body that orbited Earth, and by the 18th century to something that directly orbited the Sun when the heliocentric model of Copernicus, Galileo and Kepler gained sway. Thus, Earth became included in the list of planets, whereas the Sun and Moon were excluded. At first, when the first satellites to Jupiter and Saturn were discovered in the 17th century, the terms planet and satellite were used interchangeably, although the latter would gradually become more prevalent in the following century. Until the mid-19th century, the number of planets rose rapidly because any newly discovered object directly orbiting the Sun was listed as a planet by the scientific community. 19th century. In the 19th century, astronomers began to realize that recently discovered bodies that had been classified as planets for almost half a century were very different from the traditional ones. These bodies shared the same region of space between Mars and Jupiter, and had a much smaller mass. As a result, they were reclassified as asteroids. In the absence of any formal definition, a planet came to be understood as any large body that orbited the Sun, because there was a dramatic size gap between the asteroids and the planets, and the spate of new discoveries seemed to have ended after the discovery of Neptune in 1846. There was no apparent need to have a formal definition. 20th century. In the 20th century, Pluto was discovered. After initial observations led to the belief it was larger than Earth, the object was immediately accepted as the ninth planet. Further monitoring found the body was actually much smaller, as it was still larger than all known asteroids and seemingly did not exist within a larger population. It kept its status until 2006. In 1992, astronomers Alexander Wolszczan and Dale Frail announced the discovery of planets around a pulsar, PSR B1257+12. This discovery is generally considered to be the first definitive detection of a planetary system around another star. Then, on October 6, 1995, Michel Mayor and Didier Queloz of the Geneva Observatory announced the first definitive detection of an exoplanet orbiting an ordinary main sequence star. The discovery of extrasolar planets led to another ambiguity in defining a planet: the point at which a planet becomes a star. Many known extrasolar planets are many times the mass of Jupiter, approaching that of stellar objects known as brown dwarfs. Brown dwarfs are generally considered stars due to their ability to fuse deuterium, a heavier isotope of hydrogen. Although objects more massive than 75 times that of Jupiter fuse hydrogen, objects of only 13 Jupiter masses can fuse deuterium. Deuterium is quite rare, and most brown dwarfs would have ceased fusing deuterium long before their discovery, making them effectively indistinguishable from supermassive planets. 21st century. With the discovery during the latter half of the 20th century of more objects within the solar system and large objects around other stars, disputes arose over what should constitute a planet. There were particular disagreements over whether an object should be considered a planet if it was part of a distinct population such as a belt, or if it was large enough to generate energy by the thermonuclear fusion of deuterium. A growing number of astronomers argued for Pluto to be declassified as a planet, because many similar objects approaching its size had been found in the same region of the solar system during the 1990s and early 2000s. Pluto was found to be just one small body in a population of thousands. Some of them, such as Quaoar, Sedna, and Eris, were heralded in the popular press as the 10th planet, failing to receive widespread scientific recognition. the announcement of Eris in 2005, an object 27% more massive than Pluto, created the necessity and public desire for an official definition of a planet. Acknowledging the problem, the IAU set about creating the definition of planet, and produced one in August 2006. The number of planets dropped to the 8 significantly larger bodies that had cleared their orbit, and a new class of dwarf planets was created, initially containing 3 objects. Extrasolar planet definition in 2003. The International Astronomical Union Working Group on Extrasolar Planets made a position statement on the definition of a planet that incorporated the following working definition, mostly focused upon the boundary between planets and brown dwarfs, objects with true masses below the limiting mass for thermonuclear fusion of deuterium that orbit stars or stellar remnants, planets. The minimum mass and size required for an extrasolar object to be considered a planet should be the same as that used in the Solar System. Substellar objects with true masses above the limiting mass for thermonuclear fusion of deuterium are brown dwarfs, no matter how they formed or where they are located. Free-floating objects in young star clusters with masses below the limiting mass for thermonuclear fusion of deuterium are not planets, but are sub-brown dwarfs. This definition has since been widely used by astronomers when publishing discoveries of exoplanets in academic journals. Although temporary, it remains an effective working definition until a more permanent one is formally adopted. It does not address the dispute over the lower mass limit, and so it steered clear of the controversy regarding objects within the Solar System. This definition also makes no comment on a planetary status of objects orbiting brown dwarfs, such as 2M1207b. One definition of a sub-brown dwarf is a planet mass object that formed through cloud collapse rather than accretion. This formation distinction between a sub-brown dwarf and a planet is not universally agreed upon. Astronomers are divided into 2 camps as whether to consider the formation process of a planet as part of its division in classification. One reason for the dissent is that often it may not be possible to determine the formation process. For example, a planet formed by accretion around a star may get ejected from the system to become free-floating, and likewise a sub-brown dwarf that formed on its own in a star cluster through cloud collapse may get captured into orbit around a star. The 13 Jupiter mass cutoff is a rule of thumb rather than something of precise physical significance. The question arises, what is meant by deuterium burning? This question arises because large objects will burn most of their deuterium and smaller ones will burn only a little, and the 13 megajoules value is somewhere in between. The amount of deuterium burnt depends not only on mass but also on the composition of the planet, on the amount of helium and deuterium present. The Extrasolar Planets Encyclopedia includes objects up to 25 Jupiter masses, saying, the fact that there is no special feature around 13 megajoules in the observed mass spectrum reinforces the choice to forget this mass limit. The exoplanet Data Explorer includes objects up to 24 Jupiter masses with the advisory. The 13 Jupiter mass distinction by the IAU Working Group is physically unmotivated for planets with rocky cores, and observationally problematic due to the C and I ambiguity. The NASA Exoplanet Archive includes objects with a mass equal to or less than 30 Jupiter masses. Another criterion for separating planets and brown dwarfs, rather than deuterium burning, formation process or location, is whether the core pressure is dominated by Coulomb pressure or electron degeneracy pressure. 2006 definition. The matter of the lower limit was addressed during the 2006 meeting of the IAU's General Assembly. After much debate and one failed proposal, 232 members of the 10,000-member Assembly, who nevertheless constituted a large majority of those remaining at the meeting, voted to pass a resolution. The 2006 resolution redefines planets within the Solar System as a celestial body that is in orbit around the Sun. has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium shape, and has cleared the neighborhood around its orbit. Under this definition, the Solar System is considered to have 8 planets. Bodies that fulfill the first 2 conditions but not the third are classified as dwarf planets, provided they are not also natural satellites of other planets. After much discussion, it was decided via a vote that those bodies should instead be classified as dwarf planets. This definition is based in theories of planetary formation, in which planetary embryos initially clear their orbital neighborhood of other smaller objects. As described by astronomer Stephen Soter, the end product of secondary disk accretion is a small number of relatively large bodies in either non-intersecting or resonant orbits, which prevent collisions between them. Minor planets and comets, including KBOs, Kuiper belt objects, differ from planets in that they can collide with each other and with planets. Beyond the scientific community, Pluto still holds cultural significance for many in the general public due to its historical classification as a planet from 1930 to 2006. Objects formerly considered planets. The table below lists solar system bodies once considered to be planets.